Eighth question. Okay, so use the weak law of large number to find the value n such that this the probability of the bound is less than 0.01. Okay, so first of all, we will just put the formula, the variance. Okay, so we know that this whole value is less than or equal to sigma square by n lambda. Is that all right? Because let me write the actual formula. The law of weak number signifies that x upon n minus not 1 here, it's actually, let me write it whole in a perfect manner. Yeah, so the law of weak law of large number is probability x minus mu mod is less than delta is greater than or equal to 1 minus sigma square by n delta square. This is the actual formula. If we change the inequality here, we will get the value this, we will get this formula. So from this I'll be just using the formula sigma square is 1. Variance, first of all we need to find the variance here. Variance will be the real actual variance would be 1, so because it's given a lambda equals to 2n and beta equals to 1, so variance would be now here the variance would be 2n upon this is b equals to 1, but there are actually 2n number of entities, so it would be 2n square. So this will be simplified to 1 by 2n, right? So we can write it like variance of basically n number of independent gamma would be like, right? So yeah, this would be 1 by 2n. Perfect. I hope you are all right with this part, because we are just multiplying n 2n to the total variance, right? So here this would be equal to 1 by 2n into, now sigma square is 0.01 and its square would be 0.01 square, and this is less than 0. Basically it is equal to 0.1, right? Yeah, this is less than, so we can write it like to be more simplifying this, it would be 1 by 2n into 0.01 square will be less than 0.01, and from this we will get 2n is equal to, not equal to, I'm making mistakes here, 2n will be greater than 0.01 and 0.01, 0.1 raised to power 3, this would be 0.01 raised to the power 3, and n here it will divide, it would be 6 10 raised to power 6 divided by 2, 10 raised to power 6 divided by 2, or this would be equal to 5 lakhs, suppose. Yeah, 5 with 5 zeros basically. So n is greater than 5. What is it? 2 3 4 5, right? So this would be 5 lakhs. Yeah, so this is the correct option. I hope you are getting my point here, that we are just basically finding the value. First of all, we calculated in terms of n, then we compared it with 0.01. After comparing, we got n is greater than 5 lakhs, and there's only one value greater than 5 lakh, and that is eighth option, A option. That is all. To find the variance would actually be 1 for a single independent variable, and for 2n independent variables we will get the variance to be 2n upon 2n square, and this would be result in 1 by 2n. I hope you are clear with my points here. Now next question is, we need to use CLT here. So we already know that the CLT's formula is x minus n mu by sigma root n gives normal 0 to 1, 0 comma 1, right? Using this, we can say that probability of x by 2n minus 1 greater than 0.01 is less than 0.01, right? So we will add all of the x here. So it would be like, I'm saying like, we will use it like this: n independent random variables x1 up to xn, summation of those, divided by 2n. Oh, sorry, it's 2n here. And yeah, so this minus 1 is greater than 0.1. Let me just use the notes here, it would be better there. Yeah, so right now, probability x by 2n minus 1 mod is greater than 0.01. It's given like this. Now I'll be using all the values plus x2 up to xn by 2n minus 1 mod is greater than 0.01, less than 0.01. Perfect. So the probability that x, I'll use the value here like x1 up to xn minus 2n by 2n is greater than 0.01, right? So to make it more simple, we need to convert this whole value to x minus 2n by root 2n to make it a normal value, normal 0 to 1, as we did before, right? From the previous statement. So to convert this into that, I'll be multiplying the whole equation with root 2n, and from that we will be getting, wait a minute, yeah, so using that I'll be multiplying whole equation by √2n. So probability of x1 plus x2 up to xn minus 2n by √2n, the whole, yeah, would be greater than 0.01 √2n, right? And this whole would be less than 0.01. I hope you understand my point here. Why we used √2n? We used it to convert the whole into CLT formation, right? So this is what we get from this whole part. I'll be erasing this one. Yeah. So now further we can say that this value would be twice when we remove the mod here. So probability, now we already converted this whole to a CLT formation, so I can write it like Z, because I already told you guys that x minus 2n by √2n is a normal 0 to 1, so I'll be writing it like Z. So this would be Z here, right? So probability of Z, and mod Z will be removed, and we will get here 2. So 2 probability of Z greater than 0.01 √2n would be less than 0.01. Now we can write this like, I'll remove 2 and divide it here. So yeah, we can write this part as 1 minus f of z 0.01 √2n, right? So this would be less than 0.01 by 2. Now wait a minute, I'll use another pen. Now here what we are doing is, I'll remove it and substitute it here. So f of z 0.01 √2n would be greater than 1 minus 0.01 by 2, which would be 0.995, right? Now from this we can find the value of 0.995 from the normal, and this would actually be equal to fz of 2.58. We got this from the normal distribution of 0 to 1, right? So we will compare these two values. 0.01 √2n is greater than 2.58. From this, n would be equal to, not equal to, will be greater than 33282. So all the values greater than 33,282 will be our answer. So here 33,282, these two options suffice, so these will be our answers, right? Next is, let the time taken for the failure. Okay, so there are a total of 175 light bulbs, and each light bulb has distribution of failure with a parameter of 0.05, and the distribution is exponential. Okay, so we can write E of Li for all I, which is from 1 to 175. We will get 1 by 0 point, let me write it somewhere good. So E of Li for all I from 1 to 175, we will get 1 by 0.05, which is 20. Same, we will get standard deviation of I would be 20, because standard deviation is equal to mean in exponential distribution. So we need to find that the time taken in hours exceeds 1450 for all light bulbs, right? So first of all, it would be, we need to use the CLT here. So we already know that expected value is 20 and standard deviation is 20. So let us say T here. So T minus n into mean upon sigma into root n, right? This will give us normal 0, 1. Perfect. Now from this, T minus n is 175 into 20 upon sigma is 20 and root 175 will give us normal 0 to 1. Simplifying this part, we will get T minus 3500 upon 20 root 175. So to find the probability that probability T is greater than 1450 would be probability T minus 3500 would be greater than minus 2050, right? And we can rewrite this whole part as probability T minus 3500 by 20 root 175 would be greater than minus 2050 by 20 root 175. Perfect. Yeah. So sorry. Let me use this part only. So 20 upon root 75, right? So we already got probability T minus 3500 by 20 upon root 175 is less than 2050, 20 upon root 175. Now we already know that this is Z because of the probability distribution, right? We already calculated this, so we can write probability Z less than, greater than. We need to find the value for greater than. So this would be greater than equal to. So Z greater than or equal to, this would be, let me calculate this. Wait a minute. This would be 102.5 divided by root 175, approximately minus 7.74, approximately, right? So we can write this as 1 minus f of z minus 7.74. Now we need to calculate the value for minus 1.174. We already know because it's already in simplified form. So the answer would be A option, 1 minus f of z of minus 7.7. They neglected the 4 part, but it's okay. So the next question, last question is, suppose the speeds of the vehicle of a particular road are normally distributed with a mean of 3 36 mile per hour. Okay, so and the standard deviation is 2 mile per hour. Find the probability that the mean speed of 30 randomly selected vehicles would be between 34 to 44. Okay, so first of all, let us denote the speed of vehicle as x, right? So the normal x would be normal 36,4, or you can like it as 2 square because standard deviation is 2 here. Now from this, let me rewrite. Mean is 36 and standard deviation is 2. Perfect. So there are samples 1 x 2 up to x30 for 30 vehicles, and these are IID, independently identical, right? So they told us to find the probability mean speed x. So mean speed would be x1 plus x2 up to x30 divided by 30, right? This would be the mean speed, and let us denote this above part as s, right? So let us denote this part here as s. Let me use it carefully. Yeah, so to find the probability of mean speed from 34 to 44, we know that the random variable in form of x1 plus x2 up to x30 minus n into mu divided by root of n into sigma, right? This would be the normal 0 1. So we can write this part as s. So s minus n mu by sigma root n. This would be the normal 0 1, right? So let me just make this things smaller. Yeah, perfect. Now it's pretty easy to solve. So first of all, we will substitute the values. S minus 36 into mean is here 30 divided by 2 into root of 30. Perfect, right? So this would be the normal 0 to 1. Now to find this, let me just rewrite this part. Yeah, perfect. Now to find this, we will say probability, it would be 34 s by 30 here from 44, right? It would be, let me use it, 36, right? So 36 minus 2, and here this would be 36 plus 8. Yeah, so we can rewrite it like probability minus 2 s upon 30 minus 36 8. Perfect. So this would be probability minus yeah, it's pretty confusing, right? But it's okay. So next step would be minus 2 s upon 30 minus 36 into 30, right? And 8. Now I'll remove this part because there's less space here. Yeah, so from this we can conclude that now we need to convert this equation. I hope you can see my this mouse. So this into this, so we will multiply it by root 30. So probability minus 2 root 30 s minus 36 into 30 by root 30 8 root 30, right? So after this we will divide it by 2, so we can write it like probability minus 2 will be cancelled out, so it would be root 30 s minus 36 by 30 upon 2 root 30, and this would be 4 root 30, right? Perfect. Now from this we can say that the probability here would be f, we can make it z here, so this would be the z, because normal 0 to 1 can be distributed as z, so this would be z. So fz of, now this part here would be 4 root 30 minus fz minus root 30. Perfect. So this will be our answer here. You can see actually this would be 1 minus whole, so basically minus 1 and 1 would be cancelled out, and yeah, upper bound minus lower bound, the simple way of solving questions. You may already know this part, right? So let me just write it for the confirmation here. Wait a minute. F of z, not f of z, wait a minute, yeah, for any probability p of a x b would be equal to yeah, f of let us suppose x here, so x b minus f of x a, this is f here, so I use the same property to find this, right? Probability from a to z to b would be f of b minus f of a. Perfect. So we need to find this option. I suppose they are playing with me. Wait a minute, let me just use the notes here. Yeah, wait, so we need to find the same answer as that. Wait a minute, yeah, so perfect. Now this would be 4 minus, this would be 8. This is the wrong option, first of all. Wait a minute, yeah, this is wrong because this does not justify this one. So let us see on the b option, it would be f of z 8 by 2 root 30. So this would be, no, this is wrong, because this would be minus 8 by 2 root 30, and this is not actually true. So this option is wrong. This is a possible option. No, this is also wrong. No, wait a minute. So A and B are wrong, because we are not getting f of z minus root 30 in both options. Next is in C option, it would be 8 upon 2 root 30, 4 root 30 f of z, right? Minus f of z minus 2 upon 2 root 30. This would go upwards in numerator. So we will get minus of root 30. So this is the correct option, right? Here we will get 4 root 30. So this is correct. And in C option, we will not get minus root 30. Instead, we will get root 30. So this is wrong. So C is the only correct answer. This was kind of confusing, but right. Thank you.